Here we'll talk about one last carboxylic acid derivative, which are the anhydride molecules. So anhydride, that word means without water. An anhydride is a molecule with two carbonyls that are bonded by an oxygen. So we have two carbonyl bonds, and those carbonyl carbons are bonded to each other through an oxygen. And if an anhydride is in the presence of water, so if we add H2O, then the anhydride will react to form two carboxylic acid molecules, where we have the carbonyl, the oxygen from the anhydride bonded to a hydrogen from the water, plus carbonyl, the other carbonyl bonded to the OH from the water. So two carboxylic acids. So an anhydride, that molecule without water, if it is exposed to water, it can form those carboxylic acid molecules. So we'll talk about two ways to prepare anhydrides, and then in future videos we'll talk about reactivity of anhydrides. So one way to prepare an anhydride is to treat carboxylic acids with strong drying agents. So we're essentially doing the reverse of what we've shown here. So we'll say preparation with So we'll start with a carboxylic acid, and then we'll add a strong drying agent. So here's an example, and if we're forming an anhydride, we need two carboxylic acids. In this example, we'll show a specific molecule, trifluoroacetic acid. Remember that having an electronegative atom like fluorine near the carbonyl carbon increases the reactivity of that carbon. If this is our carboxylic acid and we add a drying agent, here's one strong drying agent. This is diphosphorus pentoxide. This is a strong drying agent. This looks like we have two phosphorus atoms bonded together via an oxygen, and then each phosphorus is also double bonded to two other oxygens. So I'll go ahead and add in these lone pairs just to have a complete structure. This is diphosphorus pentoxide. This is a strong drying agent. And so if we have carboxylic acids in the presence of the strong drying agent, it will remove H2O, two hydrogens and an oxygen. So our final product is the anhydride, where we've combined two of the carboxylic acid molecules and we are bonding the carbonyls together with a single oxygen. Other byproducts are complex phosphates. We're not going to worry about drawing these. So here is one strong drying agent, diphosphorus pentoxide. Carboxylic acids in the presence of that drying agent will produce the anhydride. So that is one way to produce the anhydride. Another way is to heat dicarboxylic acid, so a molecule that has two carboxylic acids, if those carboxylic acids could form a 5 or 6 membered ring anhydride. So let's look at an example here. So heating dicarboxylic acids, molecules that have two carboxylic acid functional groups, if that molecule, when producing the anhydride, could form a 5 or 6 membered ring. Here is an example. We have an ortho-substituted benzene ring with two carboxylic acids. This is a dicarboxylic acid. And this actual molecule is called phthalic acid. So if we heat this molecule we don't need any other reagents, but we allow it to melt, then the two carboxylic acid functional groups will interact with each other and form that anhydride. We still have our benzene ring, that's not changing, but now our two carboxylic acid carbonyls are bonded to each other via one oxygen atom, and we have H2O as a byproduct. So this is an anhydride, and this is called phthalic anhydride. So I have two different ways to form anhydride molecules that are shown here, and then again in future videos we'll talk about the reactivity of these anhydrides. And I haven't shown mechanisms for these reactions. You don't have to know these mechanisms. You'll just want to be able to recognize the reagents.